So in this video I'm going to be doing an example curve sketching problem, and the function we have today is f of x equals x minus 1 over x plus 2. So the first step I like to do is to find the domain of the function. And remember, the domain is the range of x values to which the function is restricted to. Notice that for f of x, the only x value that x cannot have is negative 2. Since if x has negative 2, the denominator will become equal to 0, and we know that we cannot divide a number by 0. So the domain would be all numbers except negative 2. So we would write that as from negative infinity to negative 2, and from negative 2 to positive infinity. That is all numbers left of negative 2, and all numbers right of negative 2, but not including negative 2. So next, the second step I would do is to find the intercepts of the following function. So there are two. There's a horizontal, there's a y intercept, and there's an x intercept. So the x intercept would be, occur when y is 0. When y is 0, we have 0 equals x minus 1 over x plus 2. That means x minus 1 equals 0 and x equals 1. That is our x-intercept. Our y-intercept would occur when x is 0. So if x is 0, we get f of 0 equals negative 1 over 2. So our y-intercept equals y equals negative 1/2. So the next step I would do is to find all the asymptotes of the function. There are two asymptotes. So there's a vertical asymptote and there's a horizontal asymptote. So the vertical asymptote, remember, all we need to do is look at the denominator and set that equal to 0. So we need to set x plus 2 equal to 0, and if we solve for x, we get x equals negative 2. So this would be our vertical asymptote. And our horizontal asymptote, if you look at the function, notice that the highest power variable in both the numerator and the denominator is x. So all we need to do is compare the ratio between them, and it's a 1-to-1 ratio, so the horizontal asymptote would be y equals 1. So the fourth step is where calculus is involved, and remember, we want to do the first derivative test in order to find the min and max and the intervals of increase and decrease. And remember, to do that, we need to take the derivative of the function and set it equal to 0. So first, let's find f prime x. Notice that this is a quotient rule, so we have to take the derivative of the top, which is 1, times, leaving the bottom the same, x plus 2, minus the derivative of the bottom, which is also 1, times the top, which is x minus 1, all over the bottom squared, which is x plus 2 squared. If we simplify this, we get x plus 2 minus x minus 1 all over x plus 2 squared. Notice that the x's will cancel out, so this would be equal to 2 minus 1 is 3 over x plus 2 squared. So 3 over x plus 2 squared is the derivative of f of x. And remember, we want to set this equal to 0 to find the x coordinates, so we can use the number line test to test for the intervals of increase and decrease and the min or max. So we want to set 3 over x plus 2 squared equal to 0. But notice that this function, the derivative can never equal 0, because in order for it to equal 0, the numerator has to be 0, while the denominator has to be a number. But in this case, the numerator is a 3, and the denominator cannot be equal to 0, since we can't divide a number by 0. So in this case, this fraction cannot equal 0. However, we still have to test the points at which the function is undefined, and the function is undefined at x equals negative 2. So we still have to test x equals negative 2. So in this case, if we draw a number line and put negative 2 on here, we have to test the point left of it and right of it in this function to determine the sign of what we get. So for example, if we pick a number left of negative 2, let's say we pick negative 3, notice how when we plug negative 3 in here, the bottom still is positive. We know that a positive over a positive is always positive, so left of negative 2 will give us a positive value. So we should draw an upsloping line like that. If we test the point right of negative 2, like if we pick 0 and plug it in here, notice that we also get a positive number, so a positive over positive is again an upsloping line. So since both of these are upsloping, we have no min or max. since the sign does not change left or right of negative 2, we have no minimum, no min, or max. But what we can write are the intervals of increase and decrease. If we label this side as negative infinity and this side as positive infinity, we can say from negative infinity to negative 2, the function f of x increases, and then from negative 2 to positive infinity, the function also increases. So from the first derivative test, we noted that, and from the number line test, we noted that there was no min or max, and from negative infinity to negative 2, the function was increasing, and from negative 2 to positive infinity, it was also increasing. So the fifth step is the concavity test, and remember for the concavity test, what we want to find is the second derivative of f of x, so we can set that equal to 0 and find the points of inflection and the intervals of concavity. So right now we know that f prime x equals 3 over x plus 2 squared, correct? So and we need to find f double prime x. Well, I'm going to rewrite this as 3 times x plus 2 to the negative second power. That's the exact same thing. And now I'm going to take the derivative of that. So f double prime x equals, remember, this is just a power rule, so bring down the negative 2. So it's negative 2 times 3 while keeping the inside the same. Remember, we're subtracting 1 for the exponent, minus 3. And you can't forget the chain rule. We have to multiply by the derivative of the inside, which is just 1 in this case, times 1. And if you simplify this out, we get negative 6x plus 2 to the negative third power. And if you write this in fraction form, this is equal to negative 6 over x plus 2 to the third power. Remember, now we need to set this equal to 0. So if we set negative 6 over x plus 2 to the third equal to 0, notice that no value of x can set this equal to 0, so it can't be equal to 0, since the numerator is a constant value, and the denominator cannot be equal to 0. So in this case, remember, we still have to test the points at which the function is undefined. So we still have to test x equals a negative 2. So again, draw your number line. This is called the number line test. Plot down negative 2. And remember, we're testing a point left and right of negative 2 for the sign in this function. So let's take a point left of negative 2. Let's say we pick negative 3. If we plug it in here, notice we get negative 3 plus 2, which is negative 1. Negative 1 cubed is still negative 1. Negative over a negative is a positive. So we have negative over a negative is a positive. So we have a positive slope going like that. If you pick a point right of negative 2, notice if you pick like negative 3, if you pick like 0, 0 over 2 is 2, 2 cubed is 8, negative over a positive is equal to a negative, so we have a down sloping line like that. Notice that the concavity does change, it goes from concave up to concave down. However, we can't say this is a point of inflection because that point is undefined in the function, so there are no POIs, but the concavity does change. And now we can write our intervals of concavity. If you label this as negative infinity and this as positive infinity, we can say from negative infinity to negative 2, it is concave up, and from negative 2 to positive infinity, it is concave down. Remember, concave up looks like a U shaped, and a concave down looks like a mountain. So now I just wanted to recap everything we went through. So the domain of the function, we said, is from negative infinity to negative 2, and then from negative 2 to positive infinity. We said there were two intercepts. The y-intercept was y equals negative 1/2, and the x-intercept was x equals 1. We said there were two asymptotes. The vertical asymptote was x equals negative 2, and the horizontal asymptote was y equals 1. We said that the intervals of increase and decrease were from negative infinity to negative 2, it was increasing, and from negative 2 to positive infinity, it was also increasing. We said there were no min or max, and we said the intervals of concavity from negative infinity to negative 2, it was concave up, and from negative 2 to positive infinity, we said it was concave down. We also said there was no POIs, even though there was a shift in concavity, since that point is undefined in the function. So now we're ready to actually graph our function. So here are our axes, and let's first graph our asymptotes. So we had a vertical asymptote at x equals -2, so over here. We had a horizontal asymptote at y equals 1, so along this line right here. Now let's do our intercepts. We had an x-intercept when y equals 0, and that occurred at x equals 1. So x at x equals 1, we had one intercept right here. And we also had a y-intercept when x equals 0 and y equals -1/2. So that's our y-intercept right there. And now we can use our increasing and decrease, intervals of increase and decrease, and intervals of concavity to graph the rest. So we said from -infinity to -2, the function was increasing and it was concave up. So if we look at these two things, the only thing that is increasing and concave up is this part of the u. So if you mimic that, we get a function like that. Notice we said that from -2 to +infinity, it was also increasing, so it was going like that, but it was concave down, like that. So the only part of it that looks like that is this part of the U shape. So if we mimic that, remember we have to be in this part of the 4 boxes, because that's where our 2 intercepts are. So we're going something like that. So there you go. That is the sketch of the function x minus 1 over x plus 2, and all we did was use the 5 steps that I use, and voila. That's simple. Thank you guys for watching, and please comment and subscribe below. Since I put it in dry.